Okay, I think it's time to get started for the first session of KubeCon Cloud Native Con after the keynotes. Welcome. So just as they announced in the keynotes that CNCF is now 10 years old, Cilium is also now 10 years old. This is the project update, and we're going to be talking about what has happened in the project, what we're currently doing in the project, and where we're going for the next 10 years of Cilium. So before I get started, who here in the room is using Cilium? Okay, that's great. I love to see almost all the hands up. For the people that aren't familiar with Cilium, Cilium started out as a CNI, providing cloud-native connectivity and networking. Through Hubble, it expanded into observability, and with Tetragon, it expanded into security. The Cilium project family of projects is all powered by the Linux kernel technology eBPF, which allows you to reprogram the kernel in a safe and secure way. Cilium has lots of different features covering the whole scope of networking, from CNI to load balancing, gateway API to multicast. On the observability side, Hubble gives you a service map, it gives you network flow logs and network protocol visibility, while Tetragon gives you things like runtime enforcement and deep visibility into what's happening in your kernel. Cilium just had the 1.18 release, and there's lots of exciting announcements from it. There's a lot of increased support for IP version 6, including encapsulation, kubeproxy replacement, egress gateway, and BGP. There's actually 2 talks here at KubeCon about using Cilium for IPv6 only Kubernetes. One was yesterday at CiliumCon, and there's one later in the week. There's a new load balancer control plane redesign, which helps with the scalability of Cilium, and enhancements to multi-pool IPAM, BGP route aggregation, and support for Gateway API version 1.3. On the security and observability side, Cluster Mesh has better policy isolation, there's Hubble log field support, and there's an enhanced policy dashboard to help understand what's going on in your cluster. And then all of these enhancements have really played into the day 2 operations and scale for Cilium too. So we have things like reduce policy latency by 40%, decrease the CPU usage by 43%, we have smaller images, and we now have HA for the API server communications. So lots of great things from the latest Cilium release. And with that, I'll hand it over to Neha from Microsoft to talk about how Cilium is increasing scalability of the project.
Hello, everyone. I am Neha Aggarwal. I'm an engineering manager at Microsoft and responsible for AKS networking. And today I will be talking about how, working with community, Microsoft is advancing Cilium to support the hyperscale demands of AI workloads. So a little bit of a background. Back in 2022, Microsoft embraced Cilium and made it the data plane for the Azure CNI. So what does it mean? As a stepping stone, if you see on the right side, we natively integrated the Cilium eBPF data plane into the Azure CNI, which supports millions of pod IPs, both by the overlay as well as the VNet addressing scheme. And that gives the native routing, as well as eliminates any in-cap happening in the guest. That makes the Azure CNI powered by Cilium the most performant and scalable stack for AKS. With that, since then, we have been evolving Cilium capabilities and has become the de facto stack for our enterprise customers and gives the advanced suite of all the features listed here. Advancing our journey. Now, enterprise customers are coming with a lot of scale demands. Now, as a result, we have been working with the community and enabled a very critical, pivotal feature called Cilium endpoint slices. A little bit of why we need to do it. As you scale, there is an extensive load on the API server. Now, Cilium, as you all know, you all are using Cilium. As you all know, Cilium works on the concept called identities, which basically you create these security identities using the labels, and you use them to enforce policies. And now to enforce policies, you need to maintain these IP to identities IP cache maps. So for that, every agent, which is running on every node, needs to know the state of the whole cluster. Now that exponentially increases the watch load on the API server as you see it on the upright. Now, as you scale, let's say you're scaling to 5K nodes, and you have 100 endpoints some label got changed on 100 endpoints. Now we're talking about 500K watch updates happening right away at the very second, and then making a thundering load on the API server. Now, how did we reduce it in a very high-level thing? We kind of reduced this watch load by batching the Cilium endpoints into the Cilium endpoint slices. It gave us a 3x improved. So if you're batching 100 endpoints to 10, right away you have reduced it to 10x load on the API server. And we contributed back even further an enhancement on this feature set as to why do we even need to create the Cilium endpoint. I can directly create a slice from the pod data namespace. There are further details. I don't want to add into further details into it, but if you guys are interested, there's a very interesting talk which was given yesterday by my colleagues Tamalwani and Shreya on the workings of the Cilium endpoint slice. So I highly recommend you guys to watch it, that behind the scene, how this is being built. Now, pivoting towards the observability, we had the similar control plane bottlenecks in the Hubble observability. Now, as customer demands are increasing, they want to observe their traffic. But they do not want to observe all sort of metrics for all kind of workloads. Now, in Hubble, every agent is processing the metrics, and then there is some centralized scraper which is scraping those metrics, putting those metrics back to the storage. You can apply the filters at different layer. You can filter those metrics at storage, but you're still paying the storage cost. You can filter those metrics at the scraper, but you're still paying the cost of every cogs happening on your guest. So we kind of added at the very start of the layer by enabling the network metrics filtering. Now, what you can do is you can dynamically filter the metrics you care for your workload. Let's say for your namespace, you only care about the DNS metrics. You don't care for the rest. But for your other kind of a workload which was running on the same cluster, you want the TCP metrics. So you can do all those fine tunings and grains by this dynamic config map which we upstreamed. So there is a very interesting CFP where you can use it for your kind of workloads. The second aspect, what we did is the network flow aggregation. So similar concept, where in the network flow aggregation today, the Hubble CLI flows, it's an exhaustive list of flows, all the 5-tuple packets, all the packets which are ingress and ingress into your pods. It's very useful during debugging, but again, when I'm putting into my storage, I'm paying a lot of cost. Now, I may not need all the data. I just want to aggregate all the data, whatever the data I'm getting it from my source pod or from my destination pod. So those capabilities were missing. We contributed back, made it scalable. Now you can aggregate the data if your workload doesn't want that exhaustive list, and then store it and then use it for the advanced analytics for the processing. Now, the last couple years, the world has gone crazy, is it? And as part of that, the AI workloads, they demand hyperscale, they have hyperscale demands, and they need it now. They want to run their training jobs, inferencing jobs on these hyperscale clusters, which are GPU aware, which are running at a very high speed. So if we were talking about the Cilium endpoint slice, that we enabled it for the scale, but it will still give you the same bottleneck as the previous capabilities. If I'm running on 100K, you will still hit the same control plane load, even with the Cilium endpoint slice, because now you have expanding the batches to 100K nodes. Now, how did we mitigate it? We disabled all the CRD watchers. We disabled the Cilium endpoint slices, which was required for enforcing policies. So what we offered to our AI workloads today is there are no Cilium endpoints, there's no Cilium identity generations, no CRD watchers, so your API server control plane is sane. It gives you the basic pod-to-pod connectivity. It gives you the basic service connectivity and the basic Hubble observability. Because their identities are missing, you could get some basic Hubble data, but you will not be able to massage it well with your namespace, metadata, everything. So it's definitely missing the full feature capabilities Cilium is famous for. And AI workloads, they are going to come to us. They're already knocking our doors. They want all these full capabilities. OK, that was the animation I missed. So the way we've been brainstorming internally at Microsoft, and we had a very great talk yesterday at Dev Summit as well. How do we solve the problem in hand? How do we bring all the full feature capabilities at an unprecedented scale AI workloads are asking? Now, what we've been proposing and what we've been running benchmarks internally at Microsoft is to disaggregate the control plane, the API server control plane, by running some centralized Cilium control plane, and which computes the state centrally and then passes it to all the agents. Now, that not only reduces your API server load, because now you have reduced the watches from every agent to this central control plane, and now you have some continuous stream between your control plane and your agents to update the data. You've not only reduced the API server load, but by centrally computing the state, you've also made your agents thin. Now, you don't have to, for example, this IP cache update. Now, every agent computes this IP cache update and regenerates the endpoints for the policy enforcement. Every agent is doing the policy map generation and regenerate the Cilium endpoints. We can reduce all of that by moving everything in the central control plane. So just to like a walkthrough of our initial flow, what we're going to be working on, and we're going to obviously we want to reduce the API server load by moving the IP cache into your central control plane. Then we can extend that, make the policies also computed centrally. Now your agents already have I don't want to quote it, but very initial benchmark tests from this prototype of making a centralized policy controller has already shown 20% improvement in every agent for recomputing those policies. So then we can also further enhance the scale. Every agent does not need to know the whole state. It only cares about the state of the pods which it is hosting, like the identities it cares about that workloads are running for. So we can reduce that further updates, these centralized updates by selective cache. There is already a KEP. We were talking about that KEP yesterday in the Dev Summit, which enhances the API server CRDs to now do a selective filtering based on the CRD spec labels. So we were thinking, like, that's the brainstorming we're discussing internally, like how we can embrace that as well as part of the selective cache updates. And onto the observability layer as well. You don't want every agent to compute the metadata post-processing. If you can make it enhance the Hubble relay and make it as well, use it as well for the post-processing. So those are some of the ideas. We've been benchmarking, and we've been going to submit CFPs very soon in the Cilium community. So I highly recommend for everyone to contribute and join the 6 scalability group. And it's some of the very cool re-architect, reinvent, redesigning of the things has been already started. We're working very closely with Google folks, Isovalent folks, and Microsoft on how to make Cilium ready for the next era. So, yep, that's about my talk. Thank you. So, okay.
Thank you very much, Neha. Is it my section next? I think so. Bill, yeah?
Okay, that's Thomas. Thank you.
All right, thanks. Super exciting to hear what we're doing together on AI. Definitely not what we imagined we would be doing when we started this project 10 years ago. For those who don't know me, I'm Thomas Graf. I'm one of the creators of Cilium. And Bill and Liz asked me, why don't we celebrate 10 years of Cilium? Because that's a pretty significant, big milestone. And for this, I would say, given this milestone, I want to give you a bit of background, like where we came from, like how we started relatively small and how we now collaborate with the hyperscalers to prepare for the age of AI. So it all started almost 10 years ago. It's not quite 10 years ago. It will be in December. So this was the original commit that we put into GitHub. You can see it always starts with committing a git ignore file, right? That's always the first commit into a new project. So in December, we'll actually celebrate officially 10 years Cilium. This is the original founding team, and I thought this photo is very fitting. This was actually when we celebrated, I think, 25 years of Linux kernel. This was a Linux Foundation event as well, and we all together celebrated the birthday of Linux. Hence, we're all dressed up very nicely. So you can see myself, Daniel Borkman, Madhu, and Andre Martins, the original four writing the initial version of Cilium in the first couple of months. We also obviously pitched Cilium and we presented Cilium. Was pre-KubeCon, because KubeCon wasn't quite around yet or was only getting bootstrapped. So it was LinuxCon, OSS Summit, and DockerCon as well. We also had our initial Cilium Design Summit in Switzerland. This is in the Swiss Alps. You can see the weather was not quite that great. So this was really the moment when we realized maybe it's not just about networking, but we also need to care about observability, because if you don't see where you're going, it's really hard. So obviously that was the sparking moment for Hubble. We then started talking about Cilium, and this is, you can see no AI here, so we had a very different view of how Cilium should matter. We thought IPv6 only mattered a ton, and as we saw in Bill's update, we're still working on that IPv6 aspect, and 10 years later. But you can see the overall architecture is actually still very similar to how it is today. So the use of eBPF, the translation of network intent. We didn't know about the Kubernetes API back then, but like some declarative API and pushing it down into eBPF today, that is still how Cilium is being powered today. Then DockerCon 2017 happened. Show of hands, has anybody been at DockerCon in 2017? I know it's a very, yes, I see some hands. Famous DockerCon, right? A lot of things happened. That's kind of the moment when Kubernetes happened as well. I think it's when a kind of Docker was around, very present, of course. Google just launched Kubernetes, and it was very much Docker and Kubernetes combined will rule the world. Actually, it was the first time I think I shared a stage with Liz Rice as well. I think, Liz, you gave a talk on container security and how to create a container using code. Let's fast forward. OSS Summit, a couple of years later, Batman visited our booth. You see we had some presence at a conference. Still very, very, very early days. Definitely far away from AI at this point. We actually got and founded Isovalent, and we got our first office. So you can see Martinez ironing a wall decoration here. Martinez is the original author of the kube proxy replacement that we also heard in the initial intro from Bill. We also redesigned the Cilium logo. Do some of you remember how the original Cilium logo looked like? It was all, yes, Bill, of course, yes, doesn't count. It was almost the same, but it was round. It was not using hexagons yet. It was using round logos, and obviously hexagons so much better fit for eBPF, which has the B hexagons hive. So obviously it was a match made in heaven. We had to, of course, change to hexagons. The team kept growing. Kubernetes started growing. Cloud Native started growing. So we started expanding the team to have a bigger engineering team to drive forward Cilium. And we also went skiing and actually found a picture that shows half of Bill. So the person there with the red cap, that's Bill Mulligan, taking, I guess, a selfie. Then Cilium graduated, right? It was multiple years in, and we had been a CNCF project for a while, and finally we graduated, which obviously was a really, really big moment for all of us. This was also the moment when a lot of the cloud providers started using Cilium. We just heard from Microsoft. Cilium is essentially the foundation for Azure CNI powered by Cilium. But before that, Google had started using Cilium for GKA as well. And AWS was also using Cilium for EKS Anywhere, their on-prem Kubernetes offering. So Cilium was starting to be embedded and powering a majority of the Kubernetes distribution. As Isovalent, we had another milestone shortly after that. We got acquired into Cisco, and I think very proud and very fortunate and very, I think, happy to say that we found a great home, not just for the company, but also for the overall open source project. I think Cilium is as strong as ever, and we remain 100% committed to the future of Cilium as open source project. And I think the releases that are happening and the collaboration that is happening is definitely proof of that. So the best possible outcome for an open source project that was powered by a startup. And I think, as we saw today in the update from Neha, there is strong collaboration these days around Cilium. In fact, this is a picture of the Cilium Developer Summit in Salt Lake. So we have, I would say, no longer a problem of being primarily backed by a single vendor or by a single company in the name of Isovalent. But today, there is strong collaboration and support from Google, Microsoft, Datadog, several other strong end users that all together were essentially governing and producing Cilium for the entire community. And that is definitely ensuring that the health of the project is maintained long term. Finally, actually, I had this slide as well. I wasn't sure what Neha would be talking about, but I think use of Cilium in the AI era, very crucial, and makes me very exciting to see that what we have built can be applied for the new era of AI infrastructure. When we built Cilium and we designed Cilium, we had container scalability in mind, going from VMs, maybe a couple of, or like a single-digit number of VMs per server, to a couple of dozen containers on a server. We did not have AI and large language model scale in mind when we designed Cilium. So it's very exciting that we can evolve the project to a new era that requires a new level of scalability as well. And finally, if we fast forward to today, we see Cilium being adopted by a very large number of users, whether it is as part of Kubernetes distributions, but also from a really large list of end users. You can find many of them on the Cilium website, cilium.io, with actual use cases and stories. Super exciting to read up how all of you are using Cilium on a daily basis. And with that, I would actually like to end with a big thank you to all of you for making Cilium happen together over the last 10 years. It would not have been possible on our own, just as developers of the project. We were very reliant on all of you end users very early on, giving feedback, deploying Cilium, telling us what is working, what is not working, what we could be doing better. So thank you all of you to actually making it happen together with us. Thank you. Back to you, Bill.
Great, thanks for that, Thomas. That was looking back over the last 10 years. Neha gave us looking forward for the next 10 years of Cilium in the AI era. And now I'll round out the presentation with the community updates. So I think the first one that I'm really excited about is Cilium has seen a lot of growth in the last 10 years, and we actually just recently crossed the milestone of having 1,000 contributors to the project. So I think pretty great to see all the momentum and support behind it. And as Thomas was saying, the Developer Summit is where kind of the core team all gets together. We had that yesterday, discussed a lot of things about the future of the project, from data path plugins to NetKit for bringing network scalability to VMs running on Kubernetes, and thinking about the future of the community as a whole. Yesterday, we also had a great CiliumCon North America with lots of different sessions from IPv6, Kubernetes, to deep diving into BPF code and debugging the networking data path. If you still want some more Cilium after this, there's multiple more talks. I'm really biased, but I am really looking forward to my colleague Daniel's talk about NetKit to make VM networking as fast as container networking, which will be as fast as host networking. And we've also had a lot of great case studies from the community. So this is the end users, maybe like yourself, talking about how they're using Cilium in production, from Energy Sciences Network, using Cilium for IPv6 only Kubernetes, to Echo talking about how they do supply chain management with AI and ML, to eBay talking about how they use Tetragon to secure their infrastructure. Go watch the videos or read the case studies, and if you're an end user and want to share your story with the community, come talk to me after this. We were also recently launched a State of Kubernetes Networking report just yesterday. I think this is a really fun one for me. You can see Cilium way out far ahead in terms of CNIs running on Kubernetes. I think it's also interesting to see everybody's really transitioning to Cilium for the kube proxy replacement, which provides a lot more scalability and performance in the cluster. And then that's kind of looking back, but looking forwards, what are people planning on doing to their network in the next 12 months? Things like gateway API, multi-cluster connectivity, advanced traffic management. I think the fun part and the exciting part about being part of the Cilium project is these are all features that the project has. So once you have Cilium installed as a CNI, it's just an additional feature to enable, and you have new capabilities to meet the demands of, for example, an AI workload or anywhere else you want to run Cilium. Coming soon, we also have a couple books coming up. There's going to be a Cilium up and running book from O'Reilly, a Cilium children's book, and a new white paper from the eBPF Foundation talking about how eBPF is really becoming kind of like the language for the infrastructure platform. And to wrap it out, we always like to have more people in the community. We have lots of ways to meet with the community, either on-site here at KubeCon, or we have developer meetings every week or every other week for both Cilium and Tetragon. We would love to see your face either at the Cilium booth later today, after the talk today, or online. So with that, thank you for coming.